The answer is yes. It is a rotational. Okay, just it's a rotational. Okay, now when we start moving in, I hope that I have given a quick understanding on this divergence and curl. Okay, therefore now you know what I'm trying to say as a curl and divergence. It means divergence in a simple, okay, simple divergence and curl. Okay, nothing much. This one is a volume density. It will speak about the volume density. Okay, volume density. And this one will speak about the rotation. Okay, field rotation or angular velocity. There is a difference, okay, there is a great difference between volume density and angular velocity. And the formula is product. You see, some students really get confused, okay, and therefore you must remember that there is a different, okay, with this del product f and del dot product to the f, del times with the f. Okay, therefore this is sometime they will use it here curled f. They will write here they will use diff. Okay, they will use the word diff f. Okay, therefore I want you to, this is more to the, okay, point of the surface where the things coming, the water from any what you call object, from any object it could be, no problem. Okay, from any small hole, the hole, and you can see the water coming out or water going inside of the object. Okay, that means this is, we are measuring over the volume density, but over in this case we are taking a field, the charges movement. Okay, we are trying to analyze this in terms of, is there any angular velocity of a particular movement of charges. It could be charges, most of the time it will be charges that we may calculate, but it could be anything, as I say. Okay, it could be a quantum base or cosmos base also, but the logic that we are working here is we are measuring the field. Okay, and remember, very important, this one is a scalar. This is scalar, therefore we are talking about only magnitude. Okay, here this one is number 3. Remember this, for the f times with the del f here is not equals to 0 if the case is a straight, the field that it will, this is a field, remember this is a field, this is a field as well. Okay, it will be irrotational. If it is a rotational, then you can see the f is sorry, I say, okay, I'll do right here, L times the f equals to 0. Okay, therefore here there is an angular velocity exists for the irrotational case, and this is actually is a vector. Okay, it's a vector, and the vector can be explained as it has a magnitude, again magnitude and direction. Okay, can you see that? Okay, it has a magnitude and direction. Okay, with this we already learned divergence and curled. Now let us move to what we call, okay, we are learning like a kind of ABCD now. It's a very important, please follow carefully, slowly, because this is a kind of learning slowly. Then we are going to combine this knowledge later. I will make use of this knowledge later. Okay, in the class I used to do some kind of what you call demonstration. Now I'm going to explain to you what I call line integral. Okay, I'm going to teach you what I call it as a line integral. Okay, what is line integral? Okay, in order to explain the line integral, over here I got a mouse. Maybe I can show you. Every class I used to do a kind of demonstration. I used to do kind of demonstration for the students. Something very interesting, I may say. Okay, now let's say you imagine there is something that you are seeing here. Okay, can you see this cable here? Yes, of course you can see the cable. You say, yes sir, I can see the cable. Okay, suddenly you see the cable is now not moving, right? It's not in the state of movement or in the motion state or anything. But suddenly you see, this is what you can see. This is the cable that you are watching, you are seeing in the video. Okay, suddenly I start making, there is a movement in this. You started suspect something. Hey, you know something? The cable is moving. Okay, then of course in this case you will say there is somebody behind this cable, right? Somebody is doing something, but I call it this somebody. That somebody is what I may define this somebody as a ghost here. Okay, let's say I will introduce to you the ghost concept. As you all know, there is a ghost, right? Okay, therefore I say some ghost actually is making this line move. Okay, which you cannot see. Wow, suddenly the cable is moving. Wow, that means it's some force behind this movement, but which you cannot see here. Of course you will say, sir, you are the person, right? No. Actually it could be some force which you cannot see. It's an invisible force making this cable. I call it this is a cable, but you imagine this as a line. Okay, the movement of something. Okay, now with this demonstration I able to explain to you few things. Okay, and two possibilities that making the things here. Okay, when I start, okay, don't underestimate this movement, right? Okay, two things to define. When there is this cable moved, okay, when the cable is moved or in the motion state, immediately you can conclude to the two. You should able to conclude in a two way. You cannot simply conclude in a one conclusion. It should be a two way to conclude the things. One, there are two possibilities. Okay, as you can see the cable. Okay, you all have seen, right? The cable move in the motion. Cable in the motion. Then the force is invisible. Okay, we don't know the force. You can see the force is invisible. It's not, you cannot see. Therefore there are two possibilities. Okay, I may say there are two possibilities to conclude this. What are they? One, you may say, sir, there could be a ghost. Ghost inside the cable. It's nobody expect this, right? Okay, when something moved, you cannot pretend say somebody is moving. I may say the cable itself might moved. Okay, it might take place, right? Nobody imagine that way. You will say, oh sir, you are the person moving. No, actually I am not making any movement. There could be a ghost inside the cable which making the cable move. I'm not joking here. I'm seriously, there could be some force inside there could be some force inside making the cable move. Possible, right? Okay, therefore you should see that possibility and you cannot ignore that possibility and simply you say no, is somebody outside. Yeah, the second one is yes. Okay, it could be due to the surface outside. Okay, maybe I say outside reactions. It could be outside force. It could be due to the outside force. Okay, due to the outside force, or it could be a surface. The surface. Don't say that I am alone able to give that. Outside can be a many way to see. It could be the surface here. The surface of this table can make it, the cable up like this. Okay, it's like that. Make it the wire up. Like that. Okay. Therefore, because you may say, how, sir? How can the table can react? Okay, yes. Let's say this is a some electrical table, magnetically charged or something. Then this cable also is something electronic based device or something like that. It could react. It can be a magnetic force which may push up, right? It can push up. Therefore, you cannot simply say it's not possible, right? It's due to outside force or most probably another ghost, which could be myself, which I may pull, which you cannot see here. But you cannot conclude outsiders. Always don't bring in outsiders. You try to imagine the context into that particular context. Try to imagine two-way. This one is what you are seeing. Okay, don't complain they can be outside, Don't bring in this, become an imagination. We cannot use imagination over here. We just say we can see only the two possibilities. One, the possibilities is the cable. Inside the cable, there is something, we may say, some force inside it. Or another possibility is this cable is now on the floor, on the table. Okay, they might be the cable is actually reacting to this surface. Okay, or you may say if the cable is moving, is going on and on, that means the length is moving outside of your visible these things. Maybe you may speculate they could be outside. Okay, there is an outside species coming inside and which disturbing this cable. Is it maybe pulling here and here? Okay, they could be. Okay, that is possible. Okay, now with that you managed to able to conclude there is a ghost inside the cable. Ghost here again, as you all know, I able to define the ghost as usual. The definition of the ghost can be charges. Okay, it could be electrical charges. Okay, again I define the ghost. Please don't the ghost can be charges. Okay, electrical forces, whatever. Okay, it can be a magnetic forces, electrical charges, magnetic forces, anything. Okay, therefore please I from now onwards I use the word ghost. Okay, is to simplify the representation of the invisible reaction of the force. Okay, now and therefore one thing that you can see when the simple another one more example that I may give you for the line integral. Okay, you have seen one small cable as one good example of cable is look like the cable is look like a line, right? Okay, then another good example that I may say is the pen itself. Here, this pen, you can see this is a small pen. When I just open the you can see a small tips here. Okay, this is, we can imagine this as something kind of line. Okay, small, we can see it's a tiny line, we can imagine. Okay, when I start right, then it will start flow out, flow something is a flow out of this pan, right? It could be I may imagine something kind of energy. Imagine this as an energy coming out of this pan, okay, flow to this paper, okay, and it react to. Therefore we can calculate this kind of movement of energy, okay, movement of the flow of forces, okay, in a cable, or not to say cable, small particle. I am saying the small movement of the particles can be calculated using what we call as a line integral. Okay, this is a kind of intro to you. Later I will detail out how the line integral can be used in the actual scenario. Okay, now I have given some idea to you what is this line integral anyway. Okay, do you able to follow me? Okay, hope now. Okay, now let me start with this line integral. Okay, the line integral can be defined in mathematic perspective. Is a mathematic perspective. It's something that I am going to introduce to you. Okay, you imagine there is one kind of small line moving on the surface. Therefore, can I capture this surface? Okay, can you imagine this as a coordinate system? Imagine this as a coordinate system, whereby I call it this as fx. Okay, this is x, and in this coordinate system, can I measure? Okay, can I measure this line? Okay, if I wanted to measure the line, okay, you all know how to calculate the surface. Okay, when we do integration on this surface, we will able to identify the surface, right? The area. But can I identify the length? How do I calculate the length of this curve? Okay, the curve. Okay, we are not interested in the surface. Remember, we are not interested in the surface. Therefore, imagine this as a del s. Del s. Okay, del s. I call it the small changes of this. Can I make it as small as possible? Can. Okay, and therefore, can I calculate the height here? Okay, of course I can calculate the height here. Okay, the height. Okay, then I know I able to calculate the del s. Okay, therefore f x times with the del s. Okay, for the del f, imagine this is f1. Okay, here. Okay, then I calculate. This is the area. Actually, I am not calculating the what? I am not calculating the length. Okay, I want the length of this. Okay, how to do that? Okay, let's say I combine together. First, I want you to just understand this logics of this first. Okay, combine together, I will able to get this summation of f. I will able to get the summation of this. Okay, this is how do we calculate the area, integration of the area, right? But there is one more concept that I would like to introduce to you. The logics that before, this is the calculation of the area, not yet the length. We are not calculating the length. Okay, the question here, why we should calculate the length? Okay, I'm going to explain to you the physics part of this before I introduce to you the maths. Okay, the physics here. Okay, the physics that we're going to introduce to here, in this case, a man, okay, a man walking. Imagine later I'm going to call this man as a ghost. Okay, let's say this is a ghost. Okay, ghost. This is a ghost. The ghost is actually walking on the one small line. As I can say, you can see here, this is a cable, right? Let's say the man is walking on the cable, then there is some action is taking place. Okay, then immediately you can see, wow, the cable is moving up and down. How could be this possible? immediately the simple things is there is a ghost inside. Let's say there is a ghost. We imagine that as a something ghost, and this is a line. Okay, when the man walk on the line, move. Okay, therefore you imagine the first thing here, f x y z, and this line, actually this what you call this line is can be a 3D, imagine, with the ghost. Remember, with the ghost, it means the function already incorporated with the ghost as well. Remember, the ghost also is coming together with this. Okay, it's not only the ghost actually is a movement. Actually, it's this function f x y z. The function f actually is a tracking the movement of the ghost inside here. Okay, therefore it's not a combination. I may call it this as a ghost, right? I will call it this as a ghost, the movement of the ghost. Okay, and every step of the movement, okay, I call it small changes here. Okay, here from this line to this line, this line, this line, this line. Okay, I can calculate equally divided, and if I move using small changes, I make small changes into that. It's can you see that what is going on here? This is what we call as a work. Okay, in the physics, you might learn this before, right? That means is this is not a vector. It's supposed to be a vector. Okay, okay, maybe the force times with the del s, small change. You imagine this is a f. Actually, it could be a I forgot to put it this as a vector. Okay, this should be a vector. Okay, okay, this because this is a displacement, the work. Okay, therefore this we call it as a work, or in another, okay, this is a displacement. Imagine this is a displacement. Okay, we're going to see later this is going to be a displacement. Sometimes it can be a vector, sometimes we're going to see one by one, but I don't want to confuse you first. Okay, I wanted to explain to you, this is a small displacement of this force from one to the another level. We call it that as a work, right? This is what you learned. Okay, now similarly I'm going to introduce to you one simple logics of the method number 1, and from there I'm going to give you simple calculations of how to calculate the perspective of line integral. Okay, therefore is there possibility for us to calculate what we call the this, okay, I think I missed the part of, okay, give me 1 minute. Okay, we will okay, let me finish this part first. Okay, this part first in the line integral. Okay, the length of this I will introduce to you one formula later. Okay, before that I will introduce to you a simple method 1. Okay, method 1, because I got a battery. Okay, we're going to take a break first. Okay, I'm going to introduce to you the method, and this part, okay, I haven't finished yet. This is the area when we use this as an area, but we are not calculating this yet. I'm going to show you how do we calculate the line, the length of line. Okay, we're going to calculate this, but this one, the combination we already learned before. This is a Riemann integral, right? It's a Riemann integral. We found the basic on this. Okay, but in the physics, when we say when some forces carrying this, we call it that as a displacement. Now therefore the method number 1, we call it that as a, we're going to calculate the line integral. The purpose of this class is to calculate someone f, the force is moving and moving from one distance here. Okay, we call it S here to the S. we call this as a displacement. Okay, displacement. Therefore it can be calculated, the work can be calculated, and this is F, so constant force, okay, constant force. Therefore the work will be calculated based on the F times with the S. Okay, constant force. In this is very important because the work basically is a vector component. Okay, that's a vector component. Then when we combine together, sorry, the work is a scalar, but this is F is a vector. Okay, this is a vector. Okay, okay, I will write this again here. F is a constant force. Okay, in this case we're going to see the constant force later. This is you already learned in your form 5 and form 6, right? Okay, any constant force. Later we are not going to use the constant force. We're going to use a dynamic force on this cable, okay, or in this to calculate the work. Therefore we use F is a vector as in direction of force. Okay, therefore you able to calculate what? Work. The work become a scalar. Okay, that means the vector combined with the another vector, okay, another vector displacement. Okay, the displacement is in a one directions in the same. Therefore you able to calculate the impact. Okay, the impact of the movement, right? Okay, the impact of the work. Therefore you are able to calculate the impact. Okay, this value is actually in an impact of the work. That means when the something like you knock this is a impact. You can see the impact is a work. Okay, we will calculate based on the impact. Okay, we take a break for a while, then I continue with the method. I'm going to introduce to you how many method in the line integral. You will see around I'm going to introduce to you roughly depends lah. You want more, then I can introduce, but roughly 8 method. Okay, I'm going to introduce to you 8 method. We'll see. Sometime I combine 2 method into one. Let me see. Okay, we take a break for a while, then I'll continue from there. Okay, thank you.